Alright, this video is about calculating concentrations in form of pph, or parts per hundred, and ppm, which is parts per million. Now, another way to go about saying concentration, I'm not talking about thinking really hard or anything like that, it's talking about how much solute is in a solution. Okay? Now, when I'm trying to find out how much solute is in that solution, I'm going to have two different units for that. Um, they're going to be pph, which stands for parts per hundred, which honestly is the same thing as a percent, and then you have parts per million. Now, parts per hundred, those are that unit is usually used for larger concentrations. Like, for example, if I wanted to find out the percentage of nitrogen, diatomic nitrogen in the atmosphere, I would use a percentage, because that's, our air that we breathe is a solution. So if I wanted to find out how much of something, how much of the solute, in this case nitrogen would have been a solute in that example, I would use percentage. But if I wanted to find out, say, the amount of mercury in drinking water, well, obviously we all know that mercury is poisonous, and if we have too much of it on drinking water, it could be very hazardous. So I'm not going to use something like percentage to describe the amount of mercury in drinking water, because that number would be like 0.000000000000334 percent, which is, a very, very small number, and honestly kind of cumbersome. So what we'll use is terms like parts per million, where we'll take say, instead of saying all that, all those zeros, we would just say that there's 34 parts per million mercury in water, in drinking water. Okay, so I mean that's kind of the distinction between the two. Usually parts per million is going to be for small concentrations, and then parts per hundred, or percent, is for large concentrations. Now, they're units, just like anything else, which means I can have an equivalency statement, and we can use dimensional analysis to actually convert between one and the other. And this is your relationship. There's 10,000 parts per million and 1%, or part per hundred. So if I ever gave you a parts per million concentration and said, I want you to convert it to parts per hundred, okay, for example, 6.23 times 10 to the negative 17 parts per million, and I want that in parts per hundred. So what I would do is, just like anything else, you put it over 1, and then I know that I want parts per million on bottom, so 1, 2, 3, 4, yeah, 4 parts per million for every 1 part per hundred. Okay, my parts per million will cancel out. I'm left with parts per hundred, and then I'll do my division, and my answer would be 6.23 times 10 to the negative 21 parts per hundred, which makes sense because if I'm going from a smaller unit to a bigger unit, then my number is going to actually go down, which 6.2 times 10 to the 23rd, or 21st, is a smaller number than 6.23 times 10 to the negative 17th. Okay, now how does this apply to what you're doing in class? Well, you guys did a lab where you were dissolving a solute in a solvent. Particularly, you were doing salt, okay, table salt, sodium chloride, and dissolving in water at different temperatures. Okay, so if I wanted to solve, say, the concentration of that salt solution that you guys made, there would be a couple things that I need, and one of them is this equation. You would need grams, okay, or mass of the solute, and I would divide that by the mass of the solution. Now, I take that and I times it by 100, and that would give me parts per 100. If I wanted to solve for parts per million, instead of 100, I would put a million here. So if I wanted this to be million, and that would give you parts per million. So I mean, just keep that, in mind. All right. But right now, we're solving for the parts per hundred of the concentration of a salt solution. Now, important to note that you need to know what a solution is or what a solution is made of, right? Before you get into telling me what the mass is. Well, remember that a mass of a solution is equal to the mass or grams of the solute plus the mass of the solvent. Now, the mass of the solute, in this case, let's go ahead and throw a number out there and say you had in your lab 4.03 grams of sodium chloride. Okay? So you had 4.03 grams of sodium chloride. Well, you also know that you dissolved it in 25.0 milliliters of water. Well, I do have a mass of a solute. In this case, would be 4.03 grams. But I don't have a mass of the solvent. I have the volume of the solvent. So what you would need to do is you would need to look up the density of that solvent, and then you with the volume and the density solve for mass. As it turns out, the density of water of H2O is 1 gram per milliliter, which means if I had 25.0 milliliters of water, that means I also had 25.0 grams of water. So I'll go ahead and say 25.0 grams of water. So that's my solvent. I don't need to write that unit in there if I don't need to. Okay, which means my mass of my solution is going to be 29.03 grams. Okay, from there, I will go back to my original equation, and I'll go mass of my solute, which is 4.03 grams, and I divide that by my mass of my solution, which is 29.03 grams. I take that, and then I multiply by 100, and I'll get, looks like 13.88219084%. Right? Remember, you always got to put your percentage in there or write out parts per hundred because that's your unit. If you don't have a unit, you don't have an answer. Now, obviously, if we paid attention, we should know that we're not done right here because I need to pay very close attention to my significant figures. Here I have 3 sig figs here. I have 4 sig figs here. I would not use this right here as sig figs. Okay, this is an exact number. You're not going to use it. So it's down to 3 or 4. In this case, I would use 3 because it's the lower number. So in truth, my answer really is 13.9%. So in your lab, you made a 13.9% solution of sodium chloride. All right. So it's a pretty straightforward process. You guys have been calculating percentages for quite some time. The only thing different in this case is you need to be able to identify what the solvent is and solve for the mass of the solvent. But I'll tell you right now, a majority of the time, this is your solvent, which means this is going to be the density that you're going to use, which makes things easy because a milliliter of that is equal to a gram of that. So you're good. Okay? So mass of solute over mass of solution times 100 equals parts per 100. Mass of solute over mass of solution times 1,000,000 will get parts per million. All right, you guys have any questions? Make sure you ask in class.